Okay, so today we are going to start with the paper 2020 variant 2-1 paper 2. Okay. Now, see, there is no choice to answer all the questions. And another important thing, if you guys are doing the past papers previously, so in 2020 backward, we have the papers where they have asked for the data booklet that you must use the data booklet. But after uh, from 2022 onwards, instead of data booklet, they have given all that information along with the question. And at the end of the paper, you have a periodic table and the constant values. Okay, so there will be no choice in the paper. And you have to do a lot of practice because you have this time only for the past papers. Okay. The graph shows the first ionization energies of some of the elements in group 2. Okay. Write an equation for the first ionization energy of magnesium. Okay. So if you recall the definition that the ionization energy always refers to gaseous atoms and 1 mole specifically. Yeah, Banin, but the electron must be on the other side, not on the left side. Okay. So first we will write the magnesium atom and we put the state symbol gas. See, they have mentioned include state symbol. So if you don't include any state symbol, if you missed it, you will, whether your equation is correct or wrong, you will lose this mark. So in a gaseous state, then arrow, it will form magnesium plus 1 gaseous ion because the ionization energy is the energy needed to remove 1 mole of electron from 1 mole of gaseous atom. So when 1 mole of gaseous atoms releases 1 mole of electron, so each gaseous atom becomes a gaseous ion. Sorry. Each gaseous atom becomes a gaseous ion with a 1 plus charge. And then after this, we will write the electron after putting the plus between, which shows that now these are two different species which were initially together. And now from this gaseous atom, this ion is formed and the electron is released. I hope it's clear to all of you. Now, next part. Explain the observed trend in first ionization energies down the group 2. So see, these are down the group 2. If you look in the product table, you will find group 2 starting from period 2. The first one is beryllium. Then in the third period, we have magnesium. Then in the fourth period, we have calcium. Then in the fifth period, we have strontium. And then in the sixth period, we have barium. And the seventh period, we have radium as well, but usually we do not consider or include radium because it's radioactive. So if you see this question, it's of 3 marks. So you have to write 3 points that why this trend is observed. So if you observe the trend that the trend is decreasing. So if you write that, let me write it, that the first ionization energies down group 2 decreases. If you write this is the what is happening over here, what you are observing, but you are not going to get any mark for this statement because this is what you are saying, what you are seeing, right? What you are observing in the graph. They didn't ask you to state what you observed, they ask you to explain what you observe. So we have to explain. It means we have to write the reasons behind this decrease in the ionization energy. So if you write this statement, remember you are not going to get any mark. You have to write, still you need to write 3 more points to get the 3 marks. Is this clear to all of you? So the first point, we know as we move down the group, what happens? If this is of this size, beryllium, then magnesium has this size, calcium has this size, strontium has even bigger size, and barium has still even more bigger size. So the size is increasing. Yeah, Khatija, you are right, increase in shielding. But why the shielding is increasing? So the first thing is, yeah, Zoha, very good. Number of shells are increasing. Electrons increases, atomic radius increases, Musfira. You don't just write electron increases, you write number of electron shells increases. That is very important. Or instead, you can write that the distance between the nucleus and the electron increases. Is this understandable to all of you? So the first point will be uh, there is increase in electron shells, hence valence electron gets further away from the nucleus. So this is the first point which will secure, which will help me to secure only 1 mark. Now I have to secure next 2 marks as well. So as Khatija said, there is a, you know, increase in shielding. So as the number of electrons are increasing, number of electron shells are increasing, and the valence electron or valence electron gets further away from the nucleus. There are more number of inner shells, and that's why the shielding effect increases. So for second point, I will write there is increase in shielding. That will help me to secure the second mark. I still need to secure the third mark. So what will be the third point? Can anyone suggest? Yes, can anyone suggest what will be the third point? Very good, Zoha. Baneen, see, this is what it means, what you have said. Nuclear attraction. Now we have to talk about the nuclear attraction. Okay, we have to talk about the nuclear attraction. So finally, what happens due to these? Due to this, the the nuclear attraction gets weaker, right? Gets the nuclear attraction decreases, and when the nuclear attraction decreases, we need lesser energy to remove the electron, and that's why the ionization energy increases. I hope it's clear to all of you. If anyone has any issue or any query, please ask. So there is a decrease. Just give me a minute, guys. Yes, it's clear to all of you? Yes, Kev, do you have any issue? There is a decrease in nuclear attraction. Okay. So see, we covered the 3 points to get the 3 marks. And Walaikum Assalam, Hassan. Uh, Mariam, you said nuclear charge increases, but see what happens if you state this nuclear charge increases means there is a more protons. And if there would be a more proton, then it will lead to the increased attraction. But here, the nuclear charge would not be affected because the size, the distance between the valence shell and the nucleus is increasing, and further the shielding effect is also increasing. So these two makes the effect of the nuclear charge ineffective, and that's why your the ionization energy decreases because the forces of attraction gets weaker because of the greater distance and more shielding. Okay, now next part. The second ionization energy of beryllium is 1757 kilojoule per mole. Explain why the second ionization energy of beryllium is higher than the first ionization energy of beryllium. Okay, so let's have a look at this. When when it's a beryllium atom, it loses the electron, turns into beryllium positive ion, and the electron is released. So see, it's a neutral. So, and this becomes, or you can say this beryllium positive ion have a more nuclear charge because it got a positive one charge on it. But on a beryllium atom, there would be no charge. When we try to release the electron from this ion, which is beryllium positive, this one has a greater nuclear charge than this beryllium atom because it possesses a positive charge, and this beryllium atom doesn't possess any charge. And due to this charge, the size also gets smaller. That's what we have studied in periodicity, or that the cations always have a smaller size than the atom. And when the size is smaller, it means the rest of the valence shell electrons gets closer to the nucleus. And if they gets closer to the nucleus, it means there would be stronger forces of attraction. So we need a higher energy to release the electron from this, from the ion, as from the cation. Okay. So for 2 marks, we are going to write uh, positive ion has greater nuclear charge than beryllium atom, and electron is being removed from a smaller ion than atom. Yes, obviously the electron is being removed from the ion because for first ionization energy, Khatija, the electron is actually removed from atom, but when the atom has lost its electron, it becomes a it becomes a cation. So is this clear to all of you? Now, question number 2. Phosphorus, sulfur, and chlorine can all react with oxygen to form oxides. So if you see, these three belongs to period 3 of the periodic table. So this question is from periodicity probably. Phosphorus reacts with an excess oxygen to form phosphorus 5 oxide. So what does this phosphorus 5 indicates? That in this compound, phosphorus have a +5 oxidation state. And for recall, you guys must know it's a simple covalent. Can anyone recall its formula? What you didn't understand, Mariam? This C part? Yes, Banin, very good. Yes, Hassan, very good. Okay. So its formula is P4O10. Okay, 1 minute, Mariam. See, look over here. For example, let's suppose there are how many protons? Yes, Zoha, good. Yes, just wait, let me explain. Yes, how many protons are there in this nucleus? See, there are 6 protons. And if it's an atom, in its first shell, there are 2 electrons. And then in its second shell, there we have 4 electrons. Right? Now, if I have to remove the electron, I have to provide energy, and the electron which is present over here, any one of the electron is going to remove from here. Is this understandable? Yes, but yes, Mariam, but that will give you only 1 mark. You have to further explain why the positive ion, when the electron is released from the positive ion, why the energy is greater, why we need the higher energy. It is because, first thing, that see, it has a no charge, right? Because the electrons and the protons are equal. So when we look into this one, for example, here we got again 6 protons. Now we have a 2 electrons over here, and 1 electron is released from over here, which makes it a cation. So see, when it becomes a cation, it has 3 electrons in its valence shell. So if you see over here, there are positive 6 charges, but there are negative 5 charges only. So it would left with the positive 1 charge over here. But if you see over here, there are positive 6 charges and negative 6 charges. So there would be no charge over here. That's why. But due to this positive one, it gets a charge. So see, its nuclear charge is greater than the atom. That is the first point. And as the nuclear charge gets bigger, the forces of attraction gets stronger, which makes the ion smaller as compared to the atom. So if the ion gets smaller, then obviously there would be a stronger attraction between the valence electron and the nucleus, and that's why it needs a large amount of energy to remove the electron as compared to the atom. Is it clear now? Okay. Yes, Khatija had written the equation, Zoha had written the equation, good. So what they are saying, write an equation to show the reaction of phosphorus with excess oxygen. So you have to remember that phosphorus also exists as a tetraatomic molecule, P4. Okay. So when we have to write the equation, I will write P4 is reacting with oxygen. And see, this is the formula of the phosphorus 5 oxide that you have to remember, that you have to memorize. So it will form P4O10. Okay, and see here they didn't ask you to write the state symbol, so there is no need. Now we have to balance the equation. Phosphorus are balanced on both sides. On left side here, there are 2 oxygen and there are 10 oxygen on the right side. So if I'll put a coefficient 2 over here before oxygen 5 over here, it makes oxygen 10 on the left hand side as well. So that's how this equation gets balanced. Is this clear to all of you? Remember, if the examiner doesn't ask you to balance the equation, you have to balance the equation, whether the examiner asked or not asked. Okay. Now, describe the reaction of phosphorus 5 oxide with water. See how many marks it has? 2 marks. So you have to write 2 points. First thing, if you recall, the phosphorus is solid. So when the reaction occurs, that solid, what happens to the solid? They are asking the reaction of phosphorus with water. Okay, very good. Which gas, Zoha? So the first thing, yes, Banin, very good. An acidic solution will form. Phosphoric acid will form. Yes, Kubra, very good. So there are 2 points. One, that solid disappears. And second, very good, Khatija. Uh, Either you can write acidic solution is formed, or you mention the name. And further, usually when the solution, acidic solution is formed, normally the energy is released. So the reaction is exothermic. So you can write as well exothermic, but it's right now it's an extra one. So you have to write only 2 out of these 3. Is this clear to all of you? Okay, now next part. State the structure and bonding of solid phosphorus 5s oxide. So see, we have discussed the structure and bonding over here. So we will write simple molecule or simple molecular and covalent bonding. Yes, very good, Bani and Khatija. Now, next part. The 2 most common oxides of sulfur are sulfur dioxide and sulfur trioxide. If you recall their nature, both are acidic. When SO2 dissolves in water, a small proportion of it reacts with water to form a weak frosted laurie acid. So see, there are 2 terms, weak and frosted laurie. Explain the meaning of the term weak frosted laurie acid. So you have to explain what is weak acid and what is frosted laurie acid. You have to explain both the things. Yes, very good, Zoha. So when we talk about a frosted laurie acid, it's a proton donor. And when we talk about the weak acid, it's a one which dissociates partially or which dissociates incompletely in the solution. So we will write uh, it is proton donor. On instead of proton donor, you can write a hydrogen ion donor as well, because normally hydrogen ion is written as proton donor. Okay. And dissociates partially in aqueous solution. So see, 2 marks, one for explaining the weak acid and one for explaining the prostaglandin acid. Okay, is this clear? Write the equation for the reaction of SO2 with water. So see, when we dissolve sulfur dioxide with water, it will turn into an acid and sulfurous acid. Yes, very good, Hassan. Very good, Banin. Kubra, your formula is wrong. It's good. Sorry, Banin, your formula is also wrong. It's SO2. So that's what usually students do the mistake. When there is a sulfur dioxide, and when the sulfur dioxide reacts with water, you will always get sulfurous acid or sulfuric 4 acid H2SO3. Yes, good, Zoha. And good, Hassan. And when the examiner, for example, if the examiner asks you for SO3, write the equation of SO3 with water. So when SO3 reacts with the water, you will get sulfuric acid, which is H2SO4. Okay, so keep this in mind. Whenever there is a SO2, you will make sulfurous acid H2SO3. And when there is a sulfur dioxide, sulfuric acid will form on dissolving in water. Is this clear to all of you? Okay. And there is one more suggestion for you guys. When I send you the paper before the class, that watch paper I'm going to do. So it's, very effective if you guys take out the print of that paper and do solve it along when I'm solving. So it will be very effective for this. Okay. Sulfur dioxide reacts with nitrogen dioxide in the atmosphere to form sulfur dioxide and nitrogen monoxide. NO is then oxidized to form NO2. So if you have studied in atmosphere and environmental chemistry that this NO2 behaves as a catalyst. And why? Because see, here it reacts and here it is restored again. So see so that's what they have asked you. State the role of NO2 in the two-stage process. So if we are observing here that it turns into something else, and then it readily again restored itself after the reaction. So it works as a catalyst. Okay. And specifically, homogeneous catalyst, they didn't ask over here which type of a catalyst. So it doesn't matter whether you write homogeneous catalyst or just catalyst, you will get the mark. But if the examiner asks you which type of catalyst is it, and then if you didn't mention the homogeneous or heterogeneous, then you will not get them. Okay. So here, either you can write just catalyst or you can write homogeneous catalyst. Both are considered as correct. Okay. Is this clear to all of you? Okay. Now, next C part. Emission of sulfur dioxide from coal-fired power stations can be reduced by mixing the coal with the powdered limestone. Okay. Limestone is heated to form calcium oxide in reaction 1. Okay, here it is. Then this then reacts with SO2 and oxygen to form calcium sulfate in reaction 2. Okay, here we have a reaction 2. State the type of reaction occurring in reaction 1. Yes, who is going to tell me? Till tomorrow, we are going to continue this paper because I am discussing the answers with you as well. Yes, very good, Banin, Hassan. You are partially correct. Yes, Zoha, you are correct as well. So probably this paper we are going to end tomorrow, not today. Okay. So see, if you see this reaction, this solid is broken down into two simpler compounds. So that is combustion. Sorry, that is decomposition. Yes, Hassan, that is thermal decomposition, because this reaction always occur when we heat when we provide the heat to the solid calcium carbonate. So It is thermal decomposition. Is it clear to all of you? Yes, Amna, good. Kubra, cracking always occur in hydrocarbons, remember, okay? Cracking always occur in hydrocarbons. Yeah, it is necessary to write thermal decomposition. Whenever you see, because see, whenever a compound turns into two, normally an ionic one, it doesn't occur at a room temperature. We always have to provide the heat, and on heating it decomposes. So that's why we always write for a ionic compound when it turning into a simpler substances or a simpler compounds, then it's always a thermal decomposition. Like for example, if you recall this reaction of metal nitrates, when calcium nitrate decomposes, it's also form calcium oxide, nitrogen dioxide, 2 moles of nitrogen dioxide and half mole of oxygen. But see, this is an ionic as well. So ionic bonds are very strong. So if the examiner asks you to about this equation, that which type of chemical reaction is this? So it is also considered as thermal decomposition, and this one as well, because the ionic compound is turning into a simpler ones. Okay. Now, what they are saying in the next part, use the data to calculate the enthalpy change of a reaction 2. Okay. So here we got the reaction 2. Let me write the equation of reaction 2 over here. That calcium oxide is reacting with sulfur dioxide and half mole of oxygen, forming calcium sulfate. Okay. C, that is delta HF, which means enthalpy change of formation. So if you recall the enthalpy change of formation, it means that elements when reacts to form compound, and specifically 1 mole of a compound. If you see over here, this is a compound, this is a compound, and this is a compound. And if you see, this enthalpy change of formation is given for these compounds. So obviously, if I have to write the equation for these enthalpy changes, so the equation would be like this. That calcium is reacting with half mole of oxygen to form calcium oxide. Sulfur is reacting with the 1 mole of oxygen to form sulfur dioxide. And calcium plus sulfur plus 2 moles of oxygen are reacting to form calcium sulfate. So these reactions have these enthalpy changes. Is this understandable to all of you? Now, how can I make the Hess cycle? Yes, Banin, your answer. I think you sent the answer. Okay. So, yeah, it's correct. So what I have to do? I have to write these elements over here. Yes, Kubra, your answer is also correct. So see, these elements, when react with each other, they are forming calcium sulfate. And how many moles of calcium sulfate are forming? Only 1 mole. So it means I have to make this equation, this value times 1. If there are, for example, 2 moles over here, so I have to do it twice. So if there is a 1 mole, so I have to make it times 1 only. So I have to find this, right? No, it's not necessary if you will remember the formula. Otherwise, if you will make the if you will make the Hess cycle and then solve it, there is a there is a minimum risk of doing it wrong. Otherwise, sometimes you use the different formula and your answer will be incorrect then. Okay. So here I'm going to put its value, which is 1434. Now, if I put the arrow over here, so see here we are getting two compounds, right? 1 mole of calcium oxide and 1 mole of sulfur dioxide. So it means if there are 1 mole, so I have to keep them as times 1 only. So as calcium oxide is forming over here. So I will put minus 635 plus 1 mole of sulfur dioxide is forming over here. So I have to put minus 297. Is this understandable to all of you? Okay. Now, if you look at the arrows, see, these are the elements. And if you see, this is the starting point, because from here, one arrow is going over there and arrow is going over there. And then from here, it's a two-step reaction. If you see this is the two-step reaction, and here we have a one-step reaction. Is this understandable? Yes, is it clear to all of you? If anyone has any question, any query regarding this, please ask. So how you will do it, when you identified a one-step reaction and the other two-step reaction, you have to equate them. Okay. So if I make the expression, so the two-step reaction has minus 635 plus minus 297 plus x, because in this two-step we have these two values and x. Elements to compound is formation. Okay, Kev? And here it's a formation is given. So it means that elements are turning into this compound. And these elements are turning into this compound. Is it clear? And then I will equate it to minus 1434. Yes, Kev, now am I audible to you? Okay. So what I need to calculate? I need to calculate the x. So I will keep the x on one side and move all the other values to the other side. So it's minus 635 turns plus 635. Minus plus makes it minus. Okay. And then this minus 297 also turns into positive 297. Now, if you guys solve it, let me know what you will get. Is it minus 502? Yes, Kaf, is this clear or still you have any confusion? And if anyone else has any confusion, please ask. Okay. Now, see over here. Chlorine forms several oxides including Cl2O, ClO2, Cl2O6. Draw dot and cross diagrams of Cl2O show outer shell electrons only. So one important thing. Okay. Do anyone else is facing is lagging in my voice? Okay. Okay, that's fine. Kef, I'll suggest you to watch the recording today. I'll upload it. If still you have any problem, because all of the other students doesn't uh, experience any lagging in my voice. And then let me know if you have still confusion, okay? So you have to draw outer shell electrons only. So remember, we have to first see whether we are going to complete the octet of both chlorine and oxygen. So if you look at chlorine, you will find that chlorine is in group 7. So it has 7 electrons in its valence shell, right? And if it has 7 electrons in its valence shell, then it means it needs 1 electron. So it means it is going to form 1 bond only. So it means it is going to share 1 electron only. And when we talk about oxygen, if you see oxygen is in group 6. So it means it has 6 valence electrons and it needs 2 more. So it means it is going to form 2 bonds. And if it is going to form 2 bonds, it means it is going to share 2 electrons only. So see, 1 oxygen and 2 chlorine. So it means oxygen is going to be present in the middle, and then 1 chlorine over here and 1 chlorine over here. Okay. So as we have decided, chlorine is going to share 1 electron. So this chlorine shared its 1 electron. Okay. And this chlorine also share its 1 electron. Is this clear? So chlorine has 7 electrons in its valence shell. If it shared 1, so 6 are left, and you will make those 6 electrons as 3 paired around each chlorine atom. If you recall, oxygen has 6 valence electron, and it will share its 2 electron, one with this chlorine and one with this chlorine. Now, out of 6, 2 electrons are shared. Now 4 electrons are left, so you will make 2 pairs like this. Is this clear to all of you? Yes, you can use circles, but it's preferable to do not use the circles in AS level. Okay. Now, ClO2 can be prepared by reacting NaClO2 with Cl2, chlorine, sodium chloride with chlorine. Write the oxidation state of chlorine in each species in the boxes provided. Okay. So see, here they have given you the oxidation state of this chlorine, which is +3. It is because, you know, if you see the whole compound has no charge, which means that the net charge is 0. Oxygen has -2 times 2 makes it -4, and sodium is +1. So see, +1 and +3 makes it +4, and -4 makes it 0. It's an element, so it's obviously 0. So you will write 0 over here. Remember, if there is an element, it has no oxidation state but a 0. Okay. Now have a look at this compound. Its oxidation number is, its net charge is 0. So it means whatever the charge oxygen and chlorine carrying, when we add them, we get the 0. So how many oxygen over here? 2. So oxygen has a charge of -2, and there are 2 oxygen, which makes it -4. So it means this chlorine must be +4. That's why we get 0. So you will write over here +4. Yes, very good, Amna. Now in this one, it is 0. Sodium belongs to group 1. So it has a +1 oxidation number, and chlorine belongs to. So obviously, if we are getting 0, so yes, Hassan and Banin, good. So it is going to be -1. So this one would have -1 oxidation number. Is this clear to all of you? Okay. Now, oxidation, okay. Cl2O6 gas used by the reaction of ClO2 with O3. Okay. And here we got the enthalpy change. The reaction takes place at 500 Kelvin and 1000 kilopascal. Okay, so it's a pressure and it's a temperature. State and explain the effect on the yield of Cl2O6 when the experiment is carried out at 1000 Kelvin and 100 kilopascal. So what we are doing, we are increasing the temperature. So see, it's a reversible reaction. And if it's a reversible reaction, there is a rule that if you increase the temperature where the equilibrium shift, which reaction is favored? Okay, Banin, very good. Zoha, very good. So what happens to the yield? The yield would decrease because when we increase the temperature, endothermic reaction occur. And see, it's stating that it's an exothermic reaction. So it means if I increase the temperature, the backward reaction would occur, and due to this, the yield would decrease. Okay, so yield decreases because forward reaction is exothermic, hence equilibrium shifts to the left. Is this clear to all of you? Okay. So I'm leaving the class here. Tomorrow we are going to continue from the next part. Okay. So see you everyone tomorrow. Take care. Goodbye. Allah Hafiz.